in this lecture, we are going to find the confidence interval for mu. But first, let's say the setup, the assumptions about the random variable x in this section. Okay, so for today's lecture, what we have is a simple random sample of size n drawn from a population of x values. So you draw a size n sample, and you are getting the x values so that you can compute the sample mean. And that's x bar, the mean of the x values. The value of sigma, the population standard deviation of x, is known. So here we are saying that we know the sigma from all the data. It's not the standard deviation that you compute from these numbers that you just drawn. Okay, so it is not the sample standard deviation. Also, if x distribution is normal, then our method works for any sample size. If x has an unknown distribution, then we require a sample size of n is greater than or equal to 30. This is the same as the previous lecture. Okay, so pretty much it's where we get from the central limit theorem. If x is normal, x bar is normal. If we don't know if x is normal, then we need n is greater than or equal to 30. Same. Okay, an estimate of a population parameter given by a single number is called a point estimate for that parameter. And in this lecture, we are going to use x bar. Okay, you draw a sample of, say, size 10, then you are going to compute its mean, x bar, and this is the parameter you estimate for mu from the population. So you are going to use x bar to estimate mu. The margin of error, which we hear a lot, right? The margin of error is the magnitude of the difference between the sample point estimate and the true population parameter value. So here's the pretty much here's the setup. You want to know the mean of the population. You draw, say, 10 from the population. You get 10 numbers, you compute their average. The average of the 10 numbers will be x bar, and you say, okay, I use this x bar to estimate mu. Then what is my error? X bar minus mu, well, positive or negative. It could be positive, it could be negative. Taking absolute value, make it positive, is the margin of error, sorry. Okay, so finally, a C confidence interval for mu is an interval computed from sample data in such a way that C is the probability of generating an interval containing the actual value of mu. which is if you are saying I want a 99% confidence interval, you are looking for interval where the probability that your real mu sit in it is 99%. Okay, so that's the setup. All right, we have a random variable. We don't know what the mean is, but we know the standard deviation sigma of the population. And what we're going to do is, well, first of all, either it is a normal distribution or we are going to draw more than 30 numbers. Then from these numbers that you draw, you compute an average. You're going to use that to estimate, okay, I have this number, say the average of the numbers I drew is 15, then I use 15, I say, okay, then the real mean probably is between 14 and 16 with what probability, okay, anyway, that's pretty much is the idea. Now let's see examples. First example, suppose the standard deviation of X distribution is sigma equals 5.2. A random sample of size 100 has sample mean 63.5. Find a 90% confidence interval for the population mean mu. Okay, actually the computation is quite easy. But you need to know here the big word, okay, the confidence interval. When you are looking for a confidence interval, this is what you do. Okay, we're not going to do the other calculation versions, the second data right. Okay, we're not going to do that. This is a very small table you are going to find in your formula tables, formula and table packet. It's faster. Okay, let's see. So we are going to find the confidence interval for mu, but we do have a sigma of the population and also a random sample size of 100. Okay, we have n, and of course has sample mean x bar equals 63.5. You have the x bar. First step, we are going to find the critical value ZC. For the critical value ZC, you are not going to really compute it. You could, okay, you learned how to do it, but this is the quicker way. You have the table. So pretty much the critical value ZC is the number ZC with, whatever percentage is in the center. Remember, we were computing if the probability between negative z and z is 90%, negative z and positive z is 50%, 99%. The reason we were doing the two-tail thing is because actually it gives you the critical value. Okay, but having said that, yes, you can do the whole, I have two tails, divide, I take away the center, I divide by 2, I inverse normal. Yes, you can do all that to get ZC, or you can go to our formula packet and find this little table on the corner. This is table 3B. Okay, with this table, you can simply take the confidence interval level and go directly to ZC. Well, it listed the popular ones. So when C, the confidence interval level is 90%, using this table, 90% is here. So our ZC will be 1.645. Then the second step, you are going to compute the maximal margin of error E. E equals GC times sigma over square root of n. Okay, you need to add this little multiplication when you are putting it in your calculator. Okay, so your E equals GC is 1.645 times numerator sigma equals 5.2 and n is 100. So over square root of 100. And put them in your calculator, you will see E actually is 0.855. Okay, that's the first two steps. You take the confidence interval, the confidence level, you go directly to the GC, use the little table, then bring it in this formula E equals GC times sigma over square root of n, you get the maximum margin of error. Now you can try practice number 1 and number 2. Pretty much the same two steps for your example. Now, continue the last thing. The confidence interval has a lower and upper bound. So your mu sits in the middle. The confidence interval could be E less than your x bar or E more than x bar. So mu sits between x bar minus E and x bar plus E. Okay, which is this E that you computed. So our x bar is 63.5 and we computed that E is 0.855. Mu sits in the middle, 63.5 plus 0.855. Okay, mu still sits in the middle and these two numbers, you work them out. 62.645 for the subtraction and 64.355 for the addition. That's it for the whole question. You get the 90% confidence interval for mu. Okay. All right. Now you can finish your practice question number 3 and number 4. So pretty much it's my step 1, step 2 for practice 1, 2. And then step 3 for question 3. Then the whole thing over for practice number 4. Okay. Next example, suppose average pizza delivery times are normally distributed. Well, we know it's normally distributed, then we don't need to ask for the 30 numbers, sample size. With an unknown population mean and the population standard deviation of 6 minutes. So we know that sigma equals 6. The population standard deviation. A random sample of 28 pizza delivery restaurants is taken, so sample size 28, and has a sample mean delivery time of 36 minutes. So the x bar, the average from these 28 number is 36. First, we want to find an 80% confidence interval estimate for the population mean delivery time. So this is from you. We know C equals 80%. Okay. First, step 1, you go to this table. C equals 80%. You are here. GC is 1.28. Then you are going to use the E formula. By the way, the E is the maximum margin of error, is in the formula packet. Both of the formulas are in the formula packet actually. So but it's shown backward. E equals GC sigma over square root of n. That's how it is written in the formula packet. And of course, they didn't put the multiplication because attachment give you multiplication. But you need to put that multiplication in your calculator. Okay, so bring these numbers in their places. 1.28 for my ZC, sigma is 6 and N is 28. And this will give me a 1.451. Then I copy the formula above it, which is the formula for the confidence interval. X bar minus E is less than mu less than X bar plus E. Then my X bar is 36, taking away 1.451 and plus the 1.451. They are 34.549 and 37.451 with my mu sitting in the middle. And that is 80% confidence interval for mu. Same setup, second question, instead of the 80% confidence interval, we are looking for the 99% confidence interval. Well, same thing, 99%, you are getting, well, if you look here, 2.58 in the corner. ZC equals 2.58 and E equals ZC sigma over root N, where ZC is 2.58. Sigma, if you remember, a population standard deviation, sigma equals 6. And this is N. And this is X bar. 6 over square root of 28. This will give me 2.925. Then copy my interval formula. I have my X bar minus 2.925 and X bar plus 2.925. And that gives me mu sits between the 33.075 and 38.925. That is the confidence interval. What it means is that the probability, so what it means is the probability of this is true is 99%. That's what you are looking for. Okay, now you can finish the packet